as m of the marginal product. Let's take the marginal product of L divided by the marginal product of K. So this is how to compute the marginal rate of technical substitution. So the marginal product of the label that we got was alpha x over L, right? So we need to divide it by divided by the MPK, and the MPK itself is beta of x over k. So whatever we have left here now should be alpha x over L times the k we have here goes up while this comes down. That's beta of x. So x cancel x. So trivially, we end up having just alpha over L times k over beta. So we can write this as the marginal rate of technical substitution is equals to, we end up having let's relate alpha and beta together. That is alpha k over beta L. So this gives the computation for the marginal rate of technical substitution. So then to show that this sigma itself is equals to 1. So let me just give you the formula you use to show this. To compute the last one, that is to show that sigma equals to 1. Please take note of this. It is advisable you use this formula. This is sigma, right? It is equals to um, the marginal product for the label we have, the marginal product of label, then multiplied by L over the production function given to us. The production function given to us, that is over x. So that is what we have. And then similarly, you must add it with, after you get this expression, so you have to multiply, you have to add it with the marginal product of the capital multiplied by, you use, when you have label here, so here to here will be capital over x. So that's how to show that sigma is equals to 1. So then you have sigma equals to, the result I got here was what? What's MPL? MPL is alpha x over L. I have alpha x over what? Over L. So I need to multiply this by what? L over x, right? So then plus the MPK. I have my MPK as beta x over k. So I have beta of x over k, and then I have it as times k over x. Now if this cancel this and this cancel this, k cancel k and x cancel x, whatever I have left now is just alpha plus beta. But do you believe, we believe that beta itself, beta is equivalent to 1 minus alpha, okay, as 1 minus alpha. So then I will end up having sigma equals to alpha plus beta is 1 minus alpha. So I will end up having alpha plus 1 minus alpha. This cancel this, and hence sigma, sorry, I have alpha plus 1 minus alpha here. So by the time I add it up, I have alpha plus 1 minus alpha. This cancel this, hence alpha is equals to 1. But if you do not really get the concept in this case, if you are still not okay with this solution, then we can decide to recall. As you can see, this is sigma is equals to 1 trivially. So let's take it elsewhere. Suppose we have this same formula. Let's recall. I said this is the formula. We have it as MPL times L over X, right? Then plus, we also have MPK times K over X, right? So if you have this, recall that MPL, not in terms of production function. I want to pick MPL, the one we actually have in terms of what? AKB. So as you can see, MPL, we have this expression here. We have alpha A K beta, then this is what we have. So if I substitute back to this case, I have alpha of A k raised to the power of beta times L raised to the power of alpha minus 1, then times L over X. And X itself is the production function, and the production function is AL alpha K beta. I have it as AL alpha K beta, right? So by the time we substitute the production function into this case, so we have it as this, then plus, recall that our MPK in terms of the, not in terms of production function, but in terms of the expression itself, MPK, we have it as beta of AL, beta of AL alpha, then K is power of beta minus 1. So that's our MPK. Then remember that we still have to multiply it by K all over the production function given to us. And the production function is, we have it as AL alpha, then K is the power of what? Beta. So by the time we notice that this, we cancel this, and at the same time K is power of beta, we cancel K is power of beta, then A L alpha minus 1, L alpha minus 1 times L, that is L alpha. This will cancel this. Whatever I have left now is what? Is just alpha. Then plus, I also notice that A cancel in this case, L alpha cancel L alpha, K beta minus 1 times K, that's K beta over this. Then I will end up having beta also, so it is satisfied. And then you have to take note that in this case, beta is always equals to 1 minus alpha. Okay, so then we end up having alpha plus 1 minus alpha. Hence, sigma is equals to what? 1. So hence, that shows the proof for sigma equals to 1. So thanks for watching. Thank you.